Hi everybody, Mrs. Pesic here,
And Miss Bella here.
and we're looking at section 9.3, arithmetic sequences and series. The objectives in this section are to find the indicated terms of an arithmetic sequence and find the sums of arithmetic series. And the vocabulary, arithmetic sequence and arithmetic series.
Okay, recall that linear functions have a constant first difference. So when we did the subtraction, they would all be the same. So notice that when you graph the ordered pair, so if we graphed what they would be, so n comma a sub n of an arithmetic sequence, the points lie on a straight line. So thus you can think of an arithmetic sequence as a linear domain or a linear function with sequential natural numbers as the domain. So that's the x values. We can maybe do a little explanation here. So if it's arithmetic, that means you have the same difference. So let's maybe say the numbers like 3, 7, 11, 15, for example. All of these have a common difference of 4. So we would say that that is like a linear function. So if I wanted to say what is the domain of this, well, this is a sub 1, a sub 2, a sub 3, a sub 4. So my domain would be, 1, 2, 3, 4. And then my range would be 3, 7, 11, 15. And I'd want to put a little notation here to say it is just these values, okay? And if I were to graph those, that would be a straight line, a linear function, if I were to plot those on a graph.
Because you'd be plotting basically the ordered pairs 1, 3, 2, 7, 3, 11, and 4, 15, and those are going to end up being a nice straight line. Okay, so let's take a look at example 1a. Determine whether the given sequence could be arithmetic. If so, find the common difference and the next term. So if you look, the difference between 11 and 8 is 3. Difference between 14 and 11 is 3. Difference between 17 and 14 is 3. And between 20 and 17 is also 3. So yes, it is an arithmetic sequence because it's the same difference each time. And the common difference, which we're going to call D, is equal to 3.
Let's try our second example doing the same thing. So again, we're going to see, could it be arithmetic? And if so, find the common difference. So again, if I'm taking a look at the two of these, I want to know what's the difference. So between 1.2 and 1.9, that is a difference of negative 0.7. Between 1.2 and 0.5, again, negative 0.7. Negative 0.2 and 0.5. Got the good same pattern here, and same idea. Again, every time I'm subtracting, you want to make sure you're taking the value on the right minus the one on the left there. The order matters in how you subtract. Again, all of these are the same, so we would say that yes, this would qualify for arithmetic sequence, and my difference in this case is negative 0.7.
And we can also notice that the difference is negative because these numbers are going down. Okay, so let's try this one. Determine whether the sequence could be arithmetic. If so, find the common difference and the next term. So if we take 11 over 3 minus 11 over 2, we would have to get a common denominator here. So common denominator of 6. And so we would get, this is going to be 22 over 6 minus 33 over 6. And so that's going to be a negative 11 over 6. So that's the difference between these two, negative 11 sixths. If we try the next one, if we try and do 11 fourths minus 11 thirds, again, we need a common denominator. This time the common denominator is 12. So if I have to multiply by 3 here, that's going to be 33 over 12, and multiply by 4 over 4 here, and I'm going to get 44 over 12, and I'm getting negative 11 over 12. Not the same as negative 11 over 6, so that's why this is not an arithmetic sequence.
Each term in an arithmetic sequence is the sum of the previous term and the constant or the common difference. So this gives the recursive rule. Remember we talked about recursive already, which means it refers to the value before it. So it gives a recursive rule that a sub n is equal to a sub n minus 1, again right there, that's the part that means the previous term, plus d. So we're going to add on the common difference there. Remember, it's okay that d can be a positive or a negative if your sequence is growing or decreasing. We can also develop an explicit rule for an arithmetic sequence as well, which means you would not need to rely on the previous term to find the term that you are looking for. So here's our general rule for an arithmetic sequence. The nth term, a sub n, of an arithmetic sequence is given by a sub n equals a sub 1, which is going to be, in this case, a sub 1 would mean the first term, and then we are going to add to that the quantity n minus 1 times d, where a sub 1 is the first term and d is the common difference. Again, the n you plug in right here will be the number of whatever term we are looking for. This is going to be the explicit rule because it does not refer to the term previous to it. You do need to know the first term in order to use this, though.
Yeah, so for the explicit, you're just plugging in the term number that you want to find for n to get the term that you're trying to find. Okay, so let's take a look at this example 2. Finding the nth term of a given nth term given an arithmetic sequence. So find the 12th term of an arithmetic sequence that looks like this: 20, 14, 8, 2, negative 4. So the first step is to find the common difference. So if we're looking here, we see that the common difference, 14 minus 20, is going to be negative 6. 8 minus 14 is negative 6, and so on. These are all dropping by negative 6. So that common difference is negative 6. And step 2 is you're going to evaluate. We're trying to find the 12th term. We're going to use our formula. Our formula, remember, is a sub n equaling a sub 1 plus n minus 1 times d. We are trying to find the 12th term, so we're really trying to find a sub 12, and that's going to be equal to a sub 1, which we know is our first term, so that's 20, plus n minus 1. Remember, n is 12 in this example, so I really need 12 minus 1 times our common difference, which we already saw was negative 6. D was equal to negative 6. And so that means that when we work this out, we end up getting negative 46. All right, the 12th term of the sequence is negative 46. And you could check this if we kept the sequence going. Remember, it goes 20, 14, 8, 2, negative 4, and so on. We do get down to the 12th term is negative 46.
This brings us to our first must-do. So you want to find the 11th term of the arithmetic sequence. Again, instead of expanding that sequence and finding the 11th, why don't you try to find what the common difference is and develop that explicit formula. So we're going to use the a sub n is equal to a sub n minus 1, a sub 1 plus n minus 1 times your common difference. Okay, so use that to help you find out what it is. All right, example 3. We're going to find some missing terms here. So I want to find the missing terms in the arithmetic sequence. So we have 17, and then we know for term 2, 3, and 4, we know that they're there, we just don't know what the values are. And then we know the 5th term is negative 7. So our goal is to find what goes in spots 2, 3, and 4. So we're going to do a couple steps on how to find this, and we're going to actually use our formula that we have here. And let's get a shade up here and we can walk through it a little bit. All right, so step 1, I want to find the common difference. Now, I can't really subtract between two values here because I don't have any of the pairings that are right next to each other. So instead, we're going to use our formula and what we know. So we know the beginning term. So we know in this formula, we'll know what is in this beginning term. We know a sub 1. And we also happen to know what the 5th term is equal to. So we know if I want to find the 5th term that it is equal to negative 7. So we're going to say a sub 5, because that's the other information we know, is equal to negative 7. In my formula then, n must equal 5. So we'll plug in the first term, 17, we'll plug in 5 for n, and negative 7 for what that 5th term is equal to. Cleaning this up in my parentheses, so I'm going to subtract the 1, and I'm going to move over the 17, so I would end up with, kind of going through a couple steps here, negative 7 is equal to 17 plus 4 times d. I would subtract 17 over a little bit, maybe some work on the side. Negative 24 is equal to 4d. And dividing both sides by 4, you find out that your common difference here is going to be negative 6. Now that kind of makes sense too. If you look at this, I had made 1, 2, 3, 4 jumps that have to be the same value. So if I went from 17 over to negative 7, if I found the difference between those, well, that's a difference of negative 24. If I divide that equally by the 4 jumps I made, each jump has to be negative 6. All right, so we know what that's going to be. That's going to help us now. If we know that this has to be a difference of negative 6, 17 minus 6, my second term here is going to be 11. If I subtract 6 from that, I'll be at 5. Subtract 6 there, I'll be at -1, and that would fit the pattern to end up at -7 for my fifth term in this problem.
Okay, so let's try this one. We're finding the missing terms in this arithmetic sequence that starts 2 something 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 0. So we're trying to find the second term, the third term, the fourth term, and we know that the first term is 2 and that the fifth term is equal to 0. So again, if we try using our steps, again, we want to use that common difference formula, a sub n equaling a sub 1 plus n minus 1 times d. We're filling in for the fifth term, so we're saying a sub 5 is 0, and that's going to be equal to a sub 1, which is 2, because that was our first term, plus n minus 1, again, a sub 5, so n is 5 minus 1, and we end up getting 0 equaling 2 plus 4d. Subtract 2 from both sides, we get the -2 equals 4d, and divide both sides by 4, and we get d equals -1/2. So that is the common difference between them, and so if we just subtract 1/2 each time, that puts us at -1.5 here, -1 here, -1/2 here. Why am I doing negatives?
Yeah, this should be positive.
My bad. Sorry, everybody. Subtracting 1/2, so that's 1.5. Subtracting 1/2 from that, I get 1. Subtracting 1/2, I get 1/2. Subtracting 1/2 again, I'm back to 0 where I wanted to be.
Okay, again, we're going to look at how to find some missing terms in a sequence here. And in this problem, I'm looking for the fifth term of the arithmetic sequence when I know that a sub 8 is 85, so the 8th term is 85, and a sub 14 is 157, so the 14th term is 157. So my goal here is to find the fifth term. Well, I'm not going to, write all these out, but I know I have 8, and then I have some in here, all up to 14 is 157. So if I think about that, my formula that I would normally use is a sub n is equal to a sub 1 plus, again, n minus 1 times d. So that's the formula we used in the past. However, I don't know what my first term is, so that's not really going to help me, and I don't have my difference yet, so using this pattern right away isn't really going to get me anywhere. Instead, I want to think about, to go from the 8th term to the 14th term, I must have made a total of 6 equal jumps, because from the 8th term to the 14th, that is a difference of 6. Okay, so I know that I made, did 6 equal jumps or steps, or whatever we want to call it. Now, what is the difference between 157 and 85? Well, if I take 157, subtract 85 from that, and figure out what my difference is in this case, that is going to be 100, let's subtract it over, 72, not 100, 72. So if I take 17 spaces, divide it equally by those 6 spaces between each of those, well, my common difference in each case must have been 12 units, which would make sense if I'm adding 12, so it's positive 12, so my sequence is getting bigger here. So I can fill in one part of my formula that the value of d, my common difference, is 12. So now, since I've got rid of one of those, eliminated one of those variables, I can now find out what my first term is. So I'm going to just say I'm going to use this information here. The 8th term is 85. So what does that tell me? If I say the 8th term, which was equal to 85, that must have been found from taking whatever my first term was and adding it to 8, because again, my 8th term, so my n is 8, 8 minus 1 times 12. So 85 is equal to my first term plus 7 times 12, or 85 is equal to my first term plus 84. So my first term must have been 1. So we're building our pattern a little bit more now. So we filled in the d first off. Now we're going to fill in what goes in this spot we just solved. So my explicit formula for this arithmetic sequence must be a sub n is equal to 1, because that was the first term we found, plus n minus 1 times 12, that common difference that we found as well. So now we can finally answer the question they were looking for, which is, what is the fifth term of this arithmetic sequence? So I'm going to plug in 5 for my n values. A sub 5 is equal to 1 plus 1 minus, 5 minus 1, plug in our n there, 5 minus 1 times 12. So a sub 5, the fifth term, is equal to 1 plus 4 times 12, or 1 plus 48. So my fifth term is equal to 49. Okay, so again, we found out that the fifth term overall is equal to 49. Again, it took a couple steps there, but we were able to derive it based on the information we were given.
Okay, so let's take a look at this example. This is similar. Find the 11th term of the arithmetic sequence. A sub 2 equals negative 133, and a sub 3 equals negative 121. So again, I think if we take a sub 3 minus a sub 2, that's the difference in the two terms we know, and divide it by 3 minus 2, because they're only one jump away, right? So we would have a negative 121 minus a negative 133 over 3 minus 2 is just 1, and we end up getting 12 again for this problem. All right, so that means that is our difference. So this could be a formula that you use to find the common difference if you just know two random terms here. And so then if we know that a sub 2 is equal to a sub 1 plus n minus 1 times d, where d is 12 in this case, we can fill in the 2 here for n, all right, and we can say that a sub 2 equals a sub 1 plus 2 minus 1. Oh, and we already know a sub 2, so I can fill that in. So a sub 2 is negative 133 equals a sub 1 plus 2 minus 1 times 12. So negative 133 equals a sub 1 plus 1 times 12. Subtracting 12 from both sides, we're getting a sub 1 equaling to negative 145. All right, so that's our starting value, and that lets us write our explicit formula, a sub n equaling a sub 1 plus n minus 1 times d. So a sub n in our case is going to be equal to our first term, which is now, we found it, negative 145, plus n minus 1 times our common difference of 12. And we can use that to find the 11th term, which is what we're trying to find. If we do this, we can say a sub 11 equals negative 145 plus 11 minus 1 times 12. That's negative 145 plus 10 times 12. Negative 145 plus 120 leaves us with negative 25. So a sub 11 equals negative 25 in this case. All right. All right, that brings up the next notes must do. You're going to find the 11th term of the arithmetic sequence. A sub 3 equals 20.5, and a sub 8 equals 13. So again, don't forget, you're going to find your common difference by doing, a sub 8 minus a sub 3 over 8 minus 3, and go from there.
So back in lesson 9.2, we wrote an evaluated series. So an arithmetic series is the indicated sum of the terms of an arithmetic sequence. So again, it's the same idea, but instead of just listing the numbers that you would have in the pattern, you're going to add all of those terms together. So you can derive a general formula for the sum of an arithmetic series by writing the series in forward and reverse order and adding the results. So there's a pattern that would arise from doing that. No, we're not going to make you do that pattern, but instead we're going to tell you what that pattern would be. So the sum of the first n terms of an arithmetic series is the product of the number of terms and the average of the first and last term. So here's an example. Let's say that our, let's just talk about this for a second. If it was a sequence, so the arithmetic sequence shown here would be 2, 4, 6, 8, 10. The series of the same value would be 2 plus 4 plus 6 plus 8 plus 10. So that's the difference there. Series adds them together. So if I wanted to know what is the sum of 2 plus 4 plus 6 plus 8 plus 10, well, the shortcut instead of actually adding all of those is we're going to multiply the number of terms. So there are 5 terms, and we're going to average my first term and my last term. So how do you find the average? Add them and divide by 2. So 2 plus 10 over 2. So we see that's 5 times 6, or 30. So in general, here's the formula that we will use. So S sub n, S stands for sum, so the sum of the first n terms is n, your number of terms, times the first term, a sub n, or sorry, a sub 1, plus the last term, a sub n, divided by 2. So average those two together. All right, so let's try to find the sum in this one. Find the indicated sum for the arithmetic series, the sum of, so S sub 18, that means the sum of the first 18 terms. And we're given a few of them, 13 plus 2 plus -9 plus -20, and so on. So how are we going to do this? Well, in order to do this, again, I know for sure that I'm doing 18 terms. So I know in my pattern that we just looked at, my formula S sub n is equal to n times a sub 1 plus a sub n divided by 2. So I need the average of the first and last terms multiplied by the number of terms. Well, I'm going to have 18 terms overall, so I know my n is 18. A sub 1 is going to be my first term, and I'm already given that because it was listed, so that's 13. So far my formula looks like, all right, 18 multiplied by our a sub 1, 13 was my first term. However, I don't know what the 18th term is. So I need to find a way to find that 18th term so I can add it in right here to the end. So that's what we're going to do first. So what's the common difference between terms? So if I think about 13 to 2, and 2 to -9, and -9 to -20, what's my pattern there? Well, the difference in each of those, if I subtracted between the first two, 2 and 13, it's a difference of -11, which makes sense because it's getting smaller. Now we're going to use that to find the 18th term. Remember my pattern here, which, well, we'll put the pattern up here first. My pattern to find those, a sub n is equal to the first term plus n minus 1 times the common difference. So my first term again is 13, and we know our common difference we just found was -11. And if I'm looking for the 18th term, I'm going to plug 18 in where that n is. So if I were to simplify that, my 18th term of this series here is -174. So in my formula up here, I now know what I need to average. This last one should be -174. So if I'm going to average those together, here we go. Oh, there we go. If I'm going to average those together in our formula, we're going to have 18. Maybe make this an n instead of a 2 here just so we're not misleading us. That's going to be -1,449 would be what you would get for adding 18 terms of that sequence.
Okay, so remember, these sums are actually partial sums. You cannot find the complete sum of an infinite arithmetic series because the term values increase or decrease indefinitely. They go on forever. So we can only find the partial sums. All right, so let's take a look at this example. Finding the sum of an arithmetic series, find the indicated sum. Struggling. Here we go. Find the indicated sum for the arithmetic series that looks like this. Remember, we have this notation with the sigma, and k equals 1 to 15 of 5 plus 2k. And again, we want to find the sum of the first 15 terms in this sequence. So we are going to add all these up. We could do this by hand. We could say, oh, if I say what is a sub 1, that would be 5 plus 2 times 1. A sub 2 is going to be 5 plus 2 times 2, and so on. So this gives me 7, this gives me 9, and so forth. So we see that we can find the first and the 15th term. That's what we need to do using our sequence. Okay, so as we're looking at this problem, again, a reminder, this symbol here, we read this as sigma, okay, and it means the sum of all of these terms. So our first term, as we said, was 7, our next term was 9, and we could keep going with this pattern, but we're really interested in using this formula to find S15, so that means we want to get a sub 15. So let's find a sub 15, and that's going to be 5 plus 2 times 15, and that's 5 plus 30, and that is 35. So we found a sub 1 is 7, and a sub 15 is 35, and so now we're plugging this in, and we get 15 times, because 15 is the number of terms we're adding. Remember, this means add all the terms from term 1 all the way up to term 15, and we get 15 is the n, a sub 1 is 7, a sub 15 is 35, and we divide by 2. And when we do that, we get 15 times 21 equals 315. And you could check using a graphing calculator, but we're not going to do that. Okay, that brings up notes must do number 3. Find the indicated sum for the arithmetic series S16. That means you want the sum of the first 16 terms in this sequence. All right, that's your third notes must do for this section. Okay, that's it for this video, and we'll see you next time.
Thanks for watching.